I want to change the font. To change the font, tools, options, enhance editor, and here in the appearance window you can see the size. Here this is the font size. Actually the default size is, I think, it will show like 8. Okay, this much or 10, but I want to increase my font. So tools, options, enhance editor. In the appearance you can put the size, some minimum 14 or 16 you can. And one more, here we have a one window. I will show you what is the importance. Okay, I think I will show you that one later better. Okay, now I have opened SAS software. First of all, understand this environment, how to use this. So that is what we'll discuss, a very basic session today. Okay, so here I have opened SAS software and this is the front end. So first of all, here you need to understand these windows. So these are called windows here. Results window, explorer window, output window, log window, editor window. So these are the windows here. SAS Windows. We need to work on these windows mainly. So first understand about these windows. Okay, in the demo we discussed about this. SAS tools, data access, data management, data analysis, data presentation. Okay, what is data access? To access the data from different data sources to SAS. Okay, in the real time while doing the projects, we need to access the data from different data sources. It could be relational databases, Oracle, Teradata, SQL whatever it may be, or non-relational, Excel, Access, text files, anything. So we can access the data by using data access here. This is the method. Next to data management. So what is the definition? We can convert raw data into SAS required format for analysis. Next to analysis part. This is completely functional part to calculate the statistics. Then this is the presentation part to generate the reports. Different types of reports. So let me give the definitions here. It's just a theory part, but it could be useful for you later. So here we can access the data from different data sources to SAS, means SAS software. We can access the data from RDBMS and non-RDBMS, both. That's the data access. Next to data management. Okay, so here data management, this one. Simple. To convert raw data into SAS required format for analysis. Otherwise, raw data into business required format for analysis. Next, third one is data analysis. It's completely functional part to calculate the statistics. Next, last one, data presentation. So here we can generate the reports. Okay, to generate the reports. So again we'll discuss about it. So here we can generate tabular reports, graphical reports, everything. So these are the four tools. Okay, next we'll discuss about these windows here. So these are the windows. 5 windows: Explorer, Editor, Log, Output, Results. Okay, 5 windows. See, Explorer, this one. Next, Editor. Next, Log. Next, Output. Next, Results. First of all, Explorer window. Okay, see it. In the Explorer window here, you can see 4 contents: libraries, file shortcuts, favorite folders, computer. So these are the 4 contents. See, libraries are nothing but folders. In SAS terminology, we are calling as libraries. In these libraries only we can store the data. Means simply in these folders only we can store the data. Here. So libraries for what? To store the data. So it's a different session. Again we'll discuss what are the types, how to create and everything. Just I'm giving the definition here. Next, file shortcuts. This one. So here we can create shortcuts to the external files. Means we can give a reference to the external files. Okay, sometimes mainly in clinical trials projects, while doing the projects we need to follow the SAP, Statistical Analysis Plan. Based on that SAP only I can generate the reports. That is my reference. Okay, that is somewhere else. You can create a shortcut for that file here. I'll show you how to create in the libraries class. So here you can open that one and you can follow the SAP, Statistical Analysis Plan. Based on the SAP we can generate the reports. These are the mock shells. So here just this is the definition. We can create a shortcut for SAS programming file, a notepad, document, anything. Next to this one, favorite folder. Favorite folders. Here we can create shortcut to the folders. Means for the entire folder we can create a shortcut here. So if you have a file you can use this. Suppose I have 20 files. For 20 files I need to create a shortcut. So then what we can do? We can save all those 20 files in one folder, and for the entire folder we can create a shortcut. Okay. That is what we can do here. For the entire folder there would be an Excel file, notepad, anything. For the entire file we can create a shortcut. Okay. So to create a shortcut for the folder. Next to this one, computer. So here we can view the system information. So on desktop also we do have this computer. The same icon I have here also. So we can see here what are the drives we have. See, D drive, E drive, C drive. and we can see the data also. Okay, this is the data here in the data. I can see the data. So these are the 4 contents from the Explorer window: libraries, file shortcuts, favorite folders, computer. Next one is the editor window. So this one, editor. So in the editor window only we can write the programs. We can develop the applications. So here. So very basic rule is this one in SAS. In SAS, every statement should be end with semicolon. So this one. Every statement should be end with semicolon. Suppose I am writing one statement, data. See, after the statement there should be semicolon. It's must. After every statement there should be semicolon. One more thing, SAS is not case sensitive like Oracle. This SAS is not case sensitive. So you can write the program either in the capital letters or small letters or mixing. It doesn't matter. See, in some programming languages it might be case sensitive, but in SAS, see, it is not case sensitive. So we can write the program either in the capital letters, small letters, mixing. It doesn't matter. Next, log window. See this one. This is the log window. So in the log window only we can trace the syntax errors, warnings, and note. Okay, I have written one program in the editor window and I have executed. After that we have to check the log window. Once you execute the program, you need to check the log window. Because here only you can trace the syntax errors. If there is any mistake, error, here you can trace. It will show that error in the red color text. Simply you can identify. Sometimes there would be a warning, that is maybe a spelling mistake also. Suppose I have given like this. Instead of this, something, suppose I have written like this, some spelling mistake. In that case, it will show a warning. Means the program can be executed, but it will show a warning in the log window with the green color text. The spelling mistake or something. Next to note, it will show in the blue color font like this. This is the blue color. Means I have executed on program successfully. So it will show how much time it has taken to execute the program. And how many columns were there, how many rows are there, everything, the total information we can see here as a note. That is the use of log window. Next, output window. So we can view the last executed program output in the output window. Okay, I have executed on program in the editor window. So where we can see the output? Here. So I have executed on program successfully. So here I can see the output in the output window. We can see the total table structure, rows, columns, everything. Next, results window. Okay, this one. So here we can see the total session outputs in a tree-like format. So understand the difference between the output window and the results window. In the output window, we can see the total output of the program, columns, rows, everything here. But here in the results window, we can see the just output name. Okay, suppose name. Okay, today I have executed 20 programs. It will show all 20 programs output names one by one. First program output name I have given A, second one B, C. Suppose A, B, C, D, E, up to like that it will show. That is called tree-like format, means one by one, step by step. Okay, once we enter into the programming, you can see that how it looks. Okay, I have executed 20 programs. Now I need to check the third program output. Here it will show the names, right? Just click on the third one. You can see the third program output here. Just here it is showing the names. If you want to see that output, just click on that link. You can see the output here in the output window. That one you can understand clearly when we are entering into the program. So these are the 5 windows here. Okay, now I have written some text in the editor window. I want to save this. Simple, Control S. So I want to save it on desktop. I have created one folder for us. So here I want to save. Okay, now see what is the name it is showing here for the editor window. SAS session November 10, because I have saved with this name. So we must save every time by giving some name, identification. Okay. Okay, next see this small point. SAS Terminology. So here in SAS, we'll follow this terminology. You can compare with the general terminology. In SAS books, even in our SAS programs, mainly we'll follow this terminology. So understand. Generally we'll call tables, but in SAS, data sets. Okay. So data sets are nothing but tables. One second. Yeah. Next to columns. But in SAS we are calling variables. Variable names. Next, generally rows or records. In SAS, observations. So generally folders, but in SAS, libraries. See? Next, subfolders. Folder in the folder. Okay, this one. In SAS, it is called catalogs. In the catalogs, only we can save the macros, formats, graphs, plots, different things. So catalogs. Generally, table name. In SAS, DSN, dataset name. So this is the SAS terminology. So remember this mainly. Next, introduction to the SAS programming steps. In SAS programming, we have 2 steps, only 2 steps. One is the data step, and second one is the procedure step. Simply are calling proc. Shortcut is proc step. Data step programs, procedure step programs. That's it. Say data step. We can create the data sets from the internal files and external files here. To create the data sets, from the internal files and external files. What is this? Okay, now I am the learner here. Just have opened the SAS software. I don't have any raw data. So in the real time, client will provide the raw data and we can work on it. But now here we don't have any raw data as we are learners. So we can create your own data set from the internal files. It means within the SAS, we can write a code. It means we can write a program and we can create a data set. I told you data set is nothing but a table. So that is called creating a data set from the internal files. Next, creating a data set from the external files. So this is what generally we'll do in the real time. Okay, I got a data in a different data sources, either Notepad, Excel, Oracle, whatever. We can write a program and by that we can import the data and we can create a data set. That is called creating a data set from the external files. So both we can do here through data step program. Next here we can do the data management. So I told you it's converting the raw data into SAS required format. There are different transformations. So like formatting the data, creating new columns, joins, update, modify, append, so on. So where we can do all this in the data step programs. So we can create the data set from the internal files. It's nothing but data entry, simply data entry. So mainly for learners, we can create our own tables for practice. Next, creating a data set from the external files. See, mainly in the clinical trials projects, you may get data in the Notepad, tab, CSV files. So we can create a data set from those external files by writing a program. Next, we can manage the data. Next, second one is this procedure step. We can calculate the statistics by using stat procedures. See, statistics. How we will calculate the statistics? Through the procedures. Those are called statistical procedures. Suppose here means, summary, univariate, so on. These are the procedure names. So means is a procedure name. Okay. By using these procedures, we can calculate the statistics. All these are predefined procedure. I will show you how to use these. Next, here we can generate tabular reports and graphical reports by using reporting procedures. These are some reporting procedures. These are the names: print, tablet, report, chart, gchart, plot, gplot, so on. By using these reporting procedures, we can generate the reports. Tabular, listing, detailed, cross tabulation in that one dimensional, two dimensional, three dimensional. And the graphical, we can generate horizontal bar, vertical bars, pie, star, donut, blocks. Okay. Tabular reports and graphical reports. Next, advanced SAS. So in advanced SAS, we'll cover mainly proc SQL first of all. Very important one. So by using proc SQL, see, I told you procedure shortcut is proc. We are using this keyword always in SAS. Proc SQL. We can connect to the databases. If you know general SQL, it would be very easy to understand. Even if you don't know SQL, no worries. We'll discuss here. So here first we'll discuss some statements. These: create, alter, insert, update, delete, drop, describe, select, so on. All basic statements. Next, set operators: union, union all, insert, intersect, except, everything. Constraints part: unique, not null, check, primary key, foreign key. This. Next, joins: inner joins, outer joins, cross joins, self joins. Next, pass-through facility. This is very important concept. We'll discuss there. Next, options and we'll cover all these concepts in the proc SQL. Next, very important one in advanced SAS, this one, macros. So these two are advanced SAS concepts. Proc SQL, macros. Just I'm giving the definition here. What is the importance of macros? For example, I derived 1,000 tables. I have imported from the different data sources. After that, I did the data management as per my requirement. Now, for these 1,000 tables, I need to generate different types of graphs. There are different types in the graphs. V-bar, 3D, H-bar, H-bar, 3D like this. Okay, if we don't know macros, then obviously we have to write 1,000 different programs to create the graphs for 1,000 tables. Just imagine how much time it may take to write 1,000 programs. But if you know macros, just will write only one macro program initially. It's a big one, but we'll write only one macro program. Then from next time onwards, from the second table onwards, no need to write the total code. So macro code, graph, it's around 6 to 7 lines code. It looks like this. See this one. This is for one table. It's around 6 to 7 lines of code. These kind of programs we have to write 1,000 because there are 1,000 tables. Just imagine how much time it may take. But instead of that, if you know macros, just will write only one macro program. It looks like this. So this is the one actually. Yes. These things we'll discuss. Like this, we'll write one macro program to create the graphs. Then from second time onwards, no need to write the total program. Just it will ask this information. What is your table name? Means data set name. Okay, bang. Which type of graph you need to generate? Okay, this time block. Between which variables? Between these two. Sales and profit. It's very easy now. Instead of writing total code, just I'm giving this information. The table name, which type of graph, between which variables. So it's so simple. So this is an importance of macros here. So here we can reduce the text and we can save the time to perform the repetitive task. Next we'll discuss ODS, Output Delivery System. By using ODS, we can send the SAS reports to the external data source in different third-party formats. We can send the reports to HTML, RTF, PDF, XML formats. As per the client specification, client requirement, he may require the reports mainly in these HTML, RTF, PDF, mainly these. Sometimes XML also. You can generate the reports. And we can send the reports in these formats as per the client requirement. So basic information. Okay, next here I will show you one program. Like this. To create data set from the internal files. It's nothing but data entry. So it may not be useful in the real time, but it is useful for the learners. Okay, now we don't have any raw data, so I will show you how to create our own tables for practice. Okay, this is the required table I need to create. Employee table with this information. Employee ID, name, salary. I need to put these observations. Okay, see the syntax. To write a program, syntax means standard method. We'll follow this. See, all data step programs starting with the keyword data. Data space data set name. So after every statement there should be a semicolon. Next, in the input statement we can give the variable names. SAS Terminology. Variable names means columns. Next, here we can enter the observations. So this is the syntax here. This is the syntax. Now I will write a program here. Data set name. So I need to give the data set name EMP. So table name. Input. In the input, these are the variable names I need to give. Employee ID, name, salary. Next, in the data lines. Sorry, here after. Data lines is the statement. In the data line statement, we need to give the observations. So these are the observations I need to give. So after all observations here, we have to give the semicolon. Remember this. Don't give the semicolon here. It's an error. If you are giving like this, it won't work. So you should give the semicolon after all observations here only. Then you can write run. This is the syntax. See, in the data statement, I have given the data set name. This. In the input statement, variable names. See here, employee ID names. Next, in the data lines statement. So here, observations. Run. Okay, observe here. I want to execute this. So select the program and submit. You can execute. But observe here one problem. We have given the variable names, employee ID, name, salary. But we didn't specify any data types here. Okay, whether it's a numeric variable or text variable, we didn't specify anything. Because here in SAS, we have only two types of data types. One is the number, another one is the text. In some databases, you can find different data types: number, text, character, varchar, blob, so on. But in SAS, only two data types. One is the number, second one is the text. And see here, number is the default data type in SAS. Number is the default one. If you didn't specify any data type, by default it will take as a number, numeric. And default length is 8. Even for text, default length is 8. We can change the default length. That we will discuss in the later program. Okay, here I have given the variable names only. I didn't specify any data type. So by default it will take all these as numeric variables only. Okay, see the problem? Select, submit. Okay, see here in SAS, one data set created. Table, name EMP. Because we have given that name. Open this. Now we have three columns: employee ID, name, salary. Okay, in employee ID it is showing the data. In salary also showing the data. But see, in name only null values, dots. Why? Okay, see here now. Right click on the data set, view columns. Okay, observe here. It's showing all three are numeric only. See, employee ID number, name number, salary number. This is the problem. Name is not the numeric variable, it's a character variable. See, in the name we have the characters. It's a character variable. So here, if you want to specify this one as a character variable, here you can keep the dollar sign. So after that variable name, keep dollar sign. So it is specifying this one as a text variable, a character variable. Okay. So here I didn't specify anything. So by default, these two are numeric variables. Here I specified dollar, so it's a character variable. Now again, select the program. See, select, and here you can find the submit button. Now again, check it. See? Employee ID. Okay, it is showing. Name. Now it is showing the names. Scott, John. Okay. Now see the data types. Right click on the data set, view columns. See now, employee ID is a number, numeric variable. Name is the text variable. Salary is a number, numeric variable. So default length is 8 for all variables. Okay. 8 bytes. You can change this. We'll discuss how to change later. So this is the basic program. How to create our own table, our own data set for practice. And here, to give the data set name and variable names, we have to follow some rules. Because here, so these are the common rules to give the data set name and variable name. See here, the data set name or variable name should start with either character or underscore only. Suppose either data set name or variable name, common rules. You can start like this. You can write like this. ICICI 1 or underscore 1 ICICI or underscore 123 means we should start with either character or underscore. Don't start with number or any other special characters like that. You should write down like this. Start with either character or underscore. It's not case sensitive. You can use write capital letters, small letters, doesn't matter. But start with a character or underscore only. So if you're writing like this, 1 ICICI, it will show an error, syntax error. The red color text you can see here. Next, the dataset name or variable name must be less than or equal to 32 characters. So minimum is 1 character, maximum 32. Suppose I'm giving a variable name like this. Okay, it will accept. Or this one, EMP salary Hyderabad. It should be less than or equal to 32 characters. It should not exceed that. Next, the dataset name or variable name accepts only underscore as a special character. Okay, I'm giving one variable name. Okay, like this. Okay, it will accept. Or you can write like this also. EMP underscore salary. You can use underscore if you want. But if you're writing like this, EMP star salary or EMP space salary, EMP like this. If you're using any other character, star space slash, it will show an error. Okay, syntax errors. So we should follow these rules while giving the dataset name and variable names. Okay, this is the basic one. So next, in the next session we can start the programming part. First we'll start with this tool, data access, to access the data from different data sources to SAS. And here we have different methods in the data access. Import procedure, SQL procedure, library reference, infile statement, wizard method, so on. We'll start with this one first of all, the very basic method, import procedure. Okay, here one more thing we need to remember this. Very basics. See, file, extension name, DBMS, Database Management System. Excel file. These are the extension names. .xls or .xlsx. DBMS Excel. Next to Access. Extension name .mdb. Microsoft Database. Excel Sheets and Microsoft Data. DBMS is Access. See like that. For every file, there is an extension name and DBMS. You should remember these because in the programs it will ask this: what are the extension names and DBMS? Just remember this. So in the next session, we'll start with the programming from here. The data access with the first method, import procedure. So these are the basics here. SAS tools. Next, Windows terminology. Introduction to the SAS programming steps. And one basic program. How to create a data set from the internal files with an example. And here some rules to give the data set name and variable names. Practice.